Good morning. Good morning, everyone. My name is Jigar Mandli. I'm a lead technical account manager based in Austin, Texas, and it's my absolute pleasure to introduce Venmo today, a true pioneer in digital payments. I have had a pleasure of supporting their journey for almost 5 years now, and year after year, I have seen them, maintain exceptional service reliability, but also push the limits of what's possible on AWS. So without further ado, let me introduce two distinguished leaders from Venmo, Maulin Vasavada, Senior Manager Software Development, and Chris Ostler, Principal Engineer at Venmo. Thank you.
Great, thank you. Those in the first row, I'm not ignoring you. The way the screens are set up, I can't see my reminders unless I'm out here. So wave your hand if you need my attention or something. Just real quick overview as we're getting in here. I'm just going to give a little bit of lead in where Venmo came from, where we're at now, and then talk about some of the problems that introduces because of that. There's some mentions about, hey, you start off small and you have to build and scale from there. I joke of that as being the mark of a successful company. When you have to start re-architecting, start talking about moving from a monolith to microservices, it means you've made it, right? And I'll talk a little about that, talk about some of our traffic patterns, what it is that we have to scale for at Venmo. And then we'll turn some time over to Maulin. He's the EM over our data and our performance engineering teams, where he can talk about some of the exercises and how we put that into practice. So Venmo was founded in 2009 by a couple of recent college graduates, and their goal and their purpose was to take the awkward out of money. They had a few too many evenings where they went out and someone had forgotten their wallet and they had to pay, figure it out, pay off the bills afterwards. And they said, hey, there's got to be a better way of doing this. And so you look at the bread and butter of Venmo has always been to the kind of that peer-to-peer aspect, sending money between friends. I see a lot of heads nodding. You can chart the traffic, the growth of that over years. You look at the number of users that we've had, and we've gone from those early days to where most recently in 2024, every month we would have 66 million active users during that month. You can see it in just the way that Venmo has become part of the culture. Someone from our marketing team looked and said, hey, someone's mentioning Venmo every couple of seconds on TikTok. And so it's just become this thing where, Venmo me has become a verb. And so at the same time that we've had that growth, we've also expanded in what our offerings are. Not only do we have just that core peer-to-peer transfer scenario, but we also have expanded that out into, well, what else can we do to make it easier for our users and help them be part of that Venmo ecosystem? And so there's things where, people are paying rent on Venmo, you're buying services, you're making online purchases through Venmo. You can have paychecks and tax returns direct deposited into your Venmo account. You can get a debit card and be able to access that balance anywhere. You can have a Venmo branded credit card. There's a whole bunch of different features that we've added into what you can do as a consumer on Venmo. What that means, though, is in addition to this core P2P traffic that we're servicing, we now have a bunch of other use cases that have a little bit different implications for what their demands are in our systems and the way that they grow when they have volumes of traffic. And so it complicates what the total landscape is for what is traffic to Venmo. So just kind of putting that in some high-level numbers here. Every year, I mentioned the 66 million monthly active users, and as an annual active user, we're seeing 90 million annual active users. There's days where we're processing more than $1 billion worth of transfers through Venmo. In a monthly basis, we see $18 billion of money flowing into the Venmo systems, and we see on average a user will visit the Venmo application 12 times a month. What that really translates to is there is a lot of different usage that we have to be aware of. And so if we look at what our traffic patterns are, Venmo is for now, a US-only offering. And so what that means is you can track our volumes pretty well with what the daytime hours are. Everyone goes to sleep. Not many people are Venmoing in the middle of the night. You can see when people start waking up and you start getting some usage, you get a little bit of a lull during the day. I guess some people have to go and work and they're not Venmoing all day long. You can see a little bit of another bump as it comes up at the end of the day, and then eventually people go back to sleep and our traffic drops off again. That's just kind of what a normal day looks like. There's other times where we see elevated traffic. If you look at Venmo patterns, you see that, hey, we do more transactions at the end of a week or at the end of a month. My family's an example of that. Hey, at the end of the month, we'll say, hey, we got, my kids' music lessons are due next month. You need to, pay for the music lessons next month. There's patterns that follow where you don't necessarily see a big difference in what the traffic looks like, but the volume is higher than what it was at other times. And then there's something entirely different. We have different times of the year where there's events that are just high volume events for Venmo, where doesn't follow any patterns. You know that, hey, there's just these times where people are using Venmo more often. There was a weekend few months ago where someone said, hey, I saw a bunch, over the weekend we saw some elevated traffic. Anyone know what it was? And I was like, Kentucky Derby. So there's these different events where we'll see traffic that doesn't follow those regular patterns. And so as we look for what does it mean for Venmo to scale to handle our traffic, there's a few different things you'd look at on a graph like that. The first one obviously is, well, what's my peak volume? What's the most traffic I ever have to support at any time? And that's kind of the easy one to fixate on, hey, how much can I do? If you do that from just kind of a naive standpoint, what you'll end up doing is we're totally scaled, we can handle that. Whenever you don't have that peak traffic, you're paying for a lot of capacity that you're not using. That's already come up in a little bit of those. So another number you'll want to start looking back at is, well, what's my low volume level? What's the least I have to spend on infrastructure during the middle of the night when everyone's asleep and no one's using it? And then you start looking at, okay, what's in between that? Okay, we have this other high volume level that here's what just kind of following our natural traffic patterns, this is the most traffic we'll get to. But then one of the things that matters a lot is what is the slope between that? If you look at kind of that growth from our normal low volume to even our elevated high volume, there's a particular slope to that. There's here's how I need to be able to spend up additional capacity for handling that traffic. But then when you get to some of these other events, you see that those slopes are much different. And so the way to prepare and respond for those is going to be different than the way that you have to do it for what your normal patterns are. And so seeing that traffic, knowing here's kind of the constraints that we're working at, here's some of the problems that we ran into in our architecture. It was originally started off as, hey, here's our monolith. We've got a MySQL database, we've got a Django application, and it all, we have a client application, and it all goes through that. It's just your very basic, simple, here's my interior architecture. Works fantastic. It goes back to your database 101 class. Hey, we need to transfer $20 from Alice's account to Bob's account, and we have to make sure we don't lose money and we don't invent money. We define a database transaction around transferring money. And so that's a great pattern to start with. Eventually, as you see these growth volumes, you say, okay, well, how can we do this a little bit more creatively? And so what we've done is we've taken that architecture and tried to break it down. What are ways that we can replace components of that with something that's more scalable? That MySQL database is vertically scaled. You provision an RDS cluster is what we're using. You choose an instance type, and that's what you get. You want something big, you pick something bigger, and eventually you get to the biggest instance and you say, well, now what? And so we've partitioned that and tried to find ways, okay, well, what data doesn't need to be atomically updated, and we can easily update our application logic to handle that. And so we partitioned out subsets of that data. We found places where we've migrated data from relational data stores to something that's inherently scalable. We've used DynamoDB, where you have, a natural inbuilt horizontal scaling built into that. We've introduced, Cassandra clusters on-prem where we're not on but that we manage, where you have something that isn't naturally horizontally scalable, it doesn't auto scale, but it has that scalability. When needed, you can add additional loads to that. Most of our application workload is on top of Kubernetes, and we've heard a little bit about being able to use that in scaling and handling, increasing and decreasing your pod counts to track volume. And so the result of this is you look through the system and you don't necessarily get to re-architect it all at once. As much as the engineers and us will say, hey, stop the presses, we're going to go heads down, talk to us in another 8 months, and we'll have you something that's golden. You have to pick, okay, what are the areas that are the most important bottlenecks? What is our biggest problem right now? And work on that while keeping everything running at the same time. So the result of that is we end up with a system where we have pockets of our system that are inherently automatically horizontally scalable. We have other places where we have some capacity for horizontal scaling, but it involves manual effort. Hey, we need to go and provision some additional nodes. And we also still have places that are vertically scalable. As much as we would love to have gotten migrated off it, there's still a lot of our core functionality running off of a MySQL instance. And so for scaling our application, it means that we have to work around all those different constraints. And so some of the problems that we run into, this idea that architecture is not all scalable, it's like, it makes sense, but what's interesting is where that intersects. Hey, I have an application running on Kubernetes, I can scale up my number of pods with this traffic, but they all have connections back to this database. And so then it's not just my CPU, my IO, and my memory and my database, but it's also just a straight connection count on that database. Auto scaling is an instant. Hey, I can scale up with my EKS. That works great for my overnight to my top of the day, even on my higher volumes. But when that high volume, high slope event hits, I can't increase that capacity fast enough to keep up with the traffic that's coming in. We run into the place, even cloud services have limits. That some of those limits are soft limits on your accounts. You work with your account manager and say, hey, I need to get some additional Lambda capacity. Great, there's numbers that can be tweaked. Some of the limits, we talk about, connection counts where, hey, we're running an RDS instance, but there's still, hard limits on some of those connection counts. And so there's portions of your system that won't be able to scale as much as you want them to. And so you have to figure out how do you work around those. Finally, someone else had alluded to this, during the year, your app changes. Go through and say, hey, we're totally prepped and scaled one year. And by the time you get back and are looking at some of those upcoming events and doing it the next year, you have a whole other set of use cases. Hey, we launched feature X, Y, and Z, feature A and B, we've changed kind of the back end implementation. And so a lot of that scaling thing, especially when you're looking at, well, what are these boundaries between what's horizontally and vertically scalable, changes year over year. And so with that, you're in this ongoing cycle of trying to identify where are my scaling constraints? What do I need to be able to do to work around them? How can I support the traffic I need to? So that's where Maulin and his team comes in.
All right. Thank you, Chris. So now let's talk a little bit about how do we deal with all of this, right? So we heavily invest in maintaining production-like performance testing environment in our ecosystem, where we run daily peak workloads on regular basis, and we keep approving our expectations on the daily peak workloads that we see from the production. We also use the same environment to run like sustained load tests for longer hours in the day to make sure we find the bottlenecks in the system for the breaking points that we need to really know. So this is how the environment setup looks like to us. Our team hosts the Locust.io framework, which is Python-based framework for performance testing, because Venmo is a Python-heavy application. Our team uses AWS EKS control plane to deploy the Locust.io to completely serverless AWS Fargate ecosystem. And then we generate the load on the target load test environment using the Locust UI. And eventually we analyze all the data and results from the Datadog observability. And we figure out the bottlenecks, and we work with partner teams to be able to figure out how do we unblock ourselves. So let's talk about some strategies that we have been able to successfully use in order to scale for the high volume traffic. So one obvious one is generally scaling out. So there are components like, ELBs, ALBs, EKS clusters that we can easily scale out based on our load test experiments and the production observability. We configure our HPS in our Kubernetes workload to automatically scale up based on the traffic demands. We also horizontally scale data stores like, AWS MSK Kafka, Cassandra on a horizontal scalable way. Just add more servers to the workload, and then, you can survive like, traffic peaks. DynamoDB, we scale in terms of like, read-write capacity and, account level quota limits and stuff. So these things we can easily kind of scale out as, to cope up with regular day-to-day peak traffic and, month-end traffic and stuff. We also actively work on tuning our traffic rules in pretty much regular fashion to be able to make sure that our traffic volume doesn't get confused with the malicious traffic and we don't get blocked. We also integrate with a lot of internal partners and external partners, like internal as in PayPal, Braintree, Stacks. So we also make sure that we work with them actively to be able to support our traffic growth patterns. So this works very well for the horizontal scalability of, first couple of graphs that you saw in the Chris's presentation slide. So now let's talk about relational data stores that we use. Primarily, it's Aurora, MySQL, and DocumentDB. Here we apply the pattern for vertical data split in order to make sure that we distribute our workloads into different clusters, be it Aurora or DocumentDB. And then, applications talk to all these different clusters based on their needs. One caveat here is that, we have to, this is not all like, how Chris was mentioning, right? This is not all day one setup, obviously, right? So we started with one monolith cluster. Eventually, as we grow, we saw the bottlenecks. We started isolating workloads in different clusters. What this also means that sometimes whatever clusters we have suddenly start getting a lot more business traffic and stuff. And we have to work on actively splitting the cluster into either multiple cluster or do a vertical scale by failing over to a different cluster. Not good. Can you go next? Yeah. Good. So now zooming out a little bit into each cluster level here. At fundamental level, we have the pattern that we use is the read-write separation of traffic. In read-write separation, the obvious benefit is that all your reads go to replicas, so your writer workload doesn't have to deal with that workload, and you can scale your write and reads independently. Other advantage in this architecture in Aurora MySQL and DocumentDB is also that you can add more and more replicas for scaling your read traffic horizontally. So this really helped us separate the traffic patterns and then focus on scaling the read and write independently. However, the writer could be just one instance, right? So this is all still multi-AZ deployment, but writer could run into bottlenecks and deadlocks. And if you run into scalability challenges because of the resources, like the threads and CPU that is allowed by underlying instance type, you need to think about failing it over or vertically scaling up, going to a bigger instance type until you run out of those options, right? So this all works very well for writer also. However, in our experience, mostly our challenges have been like we talked about horizontal scale, right, on the whole Kubernetes workload, right? And as that kept growing, our challenges have been mostly around the connection management, where, introducing the proxy for write traffic, we use RDS proxy for Aurora. That really dynamically, helps us a lot. It helps us scale for all the write traffic on different clusters, as well as, there is a limitation in replicas at some point that you could hit based on your workload volume. Like in our case, in one of the clusters, we maxed out the supported number of replicas. So we again added a proxy for the read traffic to help us scale for the read traffic connections, basically. One additional challenge we have observed in our environment is that, there has been kind of drift between the application versions as they roll out in terms of, the skew happens like all the write traffic also goes to all the read traffic also starts going to the writer. And then, periodically we have to keep monitoring for it actively and make sure that we work with our partner teams to fix their configurations or redirect that traffic properly to the replicas versus going to the writer. So let's talk a little bit about the caching solutions now. We primarily use ElastiCache as a caching solution for in-memory data cache. And this is our low latency expectations on this stack. So we are not able to use any kind of proxy solutions. And there are a couple of configuration modes for deployment that ElastiCache offers. One is the non-distributed mode here that I've listed, which is basically there is a single primary instance where all the writes can go to, and then you can add multiple replicas to keep the copy for read traffic. So this pattern works very similar to how I talked a few minutes back about the Aurora setup also. And the challenges are also similar in terms of primary. When you start kind of, exhausting all the resources, you have to think about vertically scale up or fail over to different high capacity clusters. The other deployment model is a distributed mode where you could shard your data into different shards, and then based on your needs, you can additionally add more shards to, and then of course you have to redistribute the data. But this essentially helps us scale pretty well because you can keep adding more shards, and then the traffic for those keys that the shard has goes to only that shard, all the read and writes. So now, given these two modes, right, why one would have both at all, right? If this is high, naturally scalable, why would you have the previous model? So the reason is that, it's an evolution, right, over a period of years. So initially, when we didn't have ability to do distributed mode, we started having the first clusters with non-distributed mode, right? As the traffic grew, as the workload grew, some of the new clusters went to distributed mode. We also work a lot on breaking down those monolith clusters eventually for the non-distributed mode to split into multiple clusters, either keep it in the same mode or distributed mode in the new cluster. However, it could be a challenge where if you have a non-distributed Elastic cluster, you can't easily just say, oh, now let's just go to sharded cluster. So that's something you have to keep in mind, play with it, see if it works for you. So talking about OpenSearch, which is our search use case when anybody searches for users on Venmo to pay for. This is where we keep our data. And it's very similar to like horizontal sharding that we mentioned. So I'm not going to more details, but one particular thing that we have experienced is that we have to make sure that scaling for this is not like instantaneous in seconds and minutes, because it's a search data, a lot of in-memory, cache, obviously, right? So you need to pre-plan your, scaling, go from there. So beyond all these technicalities that, we talked about, there's a lot of project management planning and, follow-ups and regular checkups, regular readiness checkpoints that we have throughout the year for variety of events, right? And like Chris mentioned, right, some of the events are, month over month traffic growth we can deal with using HPA. We keep tuning our HPA also based on our load test performance results as well as production data. But when there's a time of like traffic expectation of sudden spike in less than a minute or few minutes, then all this natural scaling doesn't work, and we spend significant amount of load testing time to analyze our system to be able to pre-scale the ecosystem across the board to be able to deal with the traffic peaks. There are some additional considerations that you can think about also based on your context. Is the figuring out your tiers of support of your business use cases, right? Because if all the it's going to be hard to be able to make trade-offs, right? So we have multiple tiers, like at least 3, and then we figure out the priorities that we have to support during the high volume traffic times. Also, we invest heavily in making sure we proactively work on taking our workloads from sync to async in whatever ways we can do, wherever it is possible, to be able to free up our response times and latency. Like Venmo is highly latency sensitive, right? Like new gen, they can't wait for a second before they give up and say click 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 to pay again, right? So. So in the summary, relating to what Chris was saying earlier, that, what has really worked well for is to be able to leverage the existing horizontal scalability abilities offered by the AWS cloud environment. In all the areas, we can easily do just, add more servers, and then you are fine. Configure your system to auto scale. It works well. And then until you start hitting the limits on the, vertical layer where you can't really easily scale, like connections on Aurora cluster, right? So then you have to figure out how do you do that, right? You decompose them, you keep constantly reiterating your architecture setup month over month, quarters over quarters, year over year. Along with this, we also need to make sure that we plan for our workloads, which we can figure out the graceful degradation for certain workloads that can really help you, shed load and then figure out like what is most important during certain time in the year. With all of this, lot of management of cost factor, obviously, like, for example, we shut down our performance test environment during night times because, as I mentioned, we invest heavily. We keep it like pretty much production parity across all data stores that we have, which means like, if you have 24XL on Aurora in production, you would keep the same on the load test environment, which is highly costly if you keep running it all the time. So cool. And the last but not the least is to just keep it, repeatedly keep testing, tuning the system. This is pretty much, this whole work goes year around. It's not a matter of like a quarter specific in the year or anything. So that really helps us keep on our, budget, as well as, making sure that we don't become the bottleneck as an infrastructure team. Good. So with that, I think, thank you. And in all of this journey, I think, like Jigar was saying, Jigar, Justin, our temps have, been with us so long. They know our system so well. They know the bottlenecks. The challenge is the uniqueness of workload that we have is that, when conversations need to happen, difficult conversations, they exactly know the context. So it has been very helpful and they have been great. Thank you.
We can take some questions. Thanks for the presentation. I'm with a gaming company, and as a consumer product, they follow a very similar daily usage volume pattern where we have very kind of low peaks and pretty high peaks. Like it could be in the order of like 5x to 7x, on a day-by-day basis. So what you guys shared about the data store, and obviously resonates very well because we know that's how we need to kind of slice and dice our data to be able to scale up over time. But I'm really curious how you guys handle the daily peaks. I mean, we've been on a search to figure out how do we kind of tune out, because databases just do not elastically scale. I mean, it seems like we have to pre-scale a lot of the databases to handle the peak load. So basically, we're paying for all that capacity we're not using. Have you guys found a solution that allows you, it doesn't even have to be on demand, even on a scheduled basis, day by day, being able to tune the databases to a lower scale to higher scale back and forth? We're still looking for that silver bullet. From one side, I think it really boils down to the horizontal versus vertical component about it. If you're a vertical scaling, you don't really have many options there. Your chance of, let me take down a big database and replace it with a small database for low volume periods is just fraught. It's like, well, I'll just keep paying for that big database instead. And so I think it really, the principle there is wherever you can, being able to find what things can we migrate out to something that is horizontally scalable, because then you have that option. But for vertically scalable, yeah, we're still looking for that silver bullet too. Let us know if you find it. Yeah. I mean, we've been trying a lot of the horizontal scalable ones, even Mongo and other things. Obviously, gives us the ability to scale, but whenever we try to scale up or down on demand by increasing or reducing SHAR, we actually make the problem worse. Like it just while all the reindexing is happening. So yeah.
One additional point, beyond technical challenges already that you know, right? the having the cost factor and the RIs, and we pay a lot of attention to our cost, and we visit our RI reservations, the projections. So we spend a lot of time in using current data to project for the next quarters and years to be able to see how, if we cannot really scale down a cluster to make sure that we deal with high daily peaks, we can at least manage our cost in a way that we know predictability right up to some extent. So that really also helps.
Yeah, my question is actually in the same direction. Like you guys use OpenSearch, which is the in-memory piece, and then you have to plan for the scaling. You put in some kind of I would say probably science or anything where you have the projected scale, and then looking backward, what actually got consumed, so that you can see maybe the lost opportunity between what you paid for versus what you actually should have been paying if you actually got it right. Do you have anything like that?
Not so far, I would say. But on top of all this, right, we also imagine our on-calls, week over week on-call handoffs, monitoring, right, monthly business reviews. We keep eye on our KPIs pretty much on daily basis to make sure how our systems are doing, right? So over provisioning up to some extent is one aspect which we try to manage through cost management and optimizing resources, right? But the other aspect is constant monitoring in some sense, beyond the regular alerts and stuff that do have, right?
A quick one. I think Chris mentioned earlier. How is your experience with Cassandra?
Yeah, maybe I should let Maulin handle that. I think that he's more
What was
directly.
the question? Sorry.
What's our experience on Cassandra? I think from my standpoint, I would say that, I'd kind of had this classification of, hey, we got vertical scaling and horizontal scaling. Cassandra is one of those ones that's in the horizontal asterisk scaling. It's not anything that you would auto scale. It's nothing that scales easily. It's one of those, it can scale. You can go through and do the exercises of partition out, but in many ways you have to treat it like it was a vertical scaled system. So from a scaling standpoint, it kind of falls into the, hey, yeah, you can repartition and do some things, but you treat it and it acts like it's a vertical scaled component.
Yeah. And what I would add to that is, like, it also depends on what do you use Cassandra for? What are your workloads also, right? Do you have a handful of clusters versus a huge ecosystem, right? So it directly relates to that, right? Basically. So if you have 10 clusters, it's very different than having 2 clusters, right? Also nature of the workload, and, there are offerings, but then if applications are not modeled right, then you are going to have problem regardless of the data stack, right? So some of those are relatable in that sense. I don't think Cassandra is any different in that. But yes, we can add horizontal workload easily and stuff. But like Chris said, we maintain it on EC2, so it's a lot of OpEx still with a lot of patching, vulnerability management, all that. So that is really something a cost heavy.
Quick question. So at GamGam, we are heavy users of Aurora global MySQL clusters as well. But as you guys mentioned, there's the challenge of right sizing the clusters because you have to actually size for the peak load. So there's a lot of wasted capacity. Have you guys tried or explored using Aurora serverless to work on that challenge?
So yes, ideal world, we want to go eventually up to some workloads. We want to experiment in that in future, most likely. But there are prereqs, right? So it takes time to even get a vision that you could find out whether it works for you. So that's where we are, I would say. Technically, I think now we have ability if we were to do it because we are on Aurora 3.x now. Earlier we were on different versions. Prior versions didn't have an ability if we wanted to explore. So we have not explored it yet. We will, this is all part of our strategy that, whatever helps in order to reduce OpEx and increase efficiency is the focus.